All right, so we are on to some CLT exponent problems, and it's worth pointing out that the rules we're going to cover in this video apply widely to the other standardized tests as well if they're doing anything with exponents. So these are just good rules to know. So for our first question, if 2 to the third power times 2 to the fifth power equals 2 to the nth power, what is n? This is a classic, no pun intended with the CLT, rule or problem. And here's rule number 1 that you need to know. When you have the same base that is multiplied, and by base this would be the number 2 in this situation, when the same base is multiplied, you actually add the exponents. Let me say that one more time. When the same base is multiplied, you add the exponents together. So in this case, we're going to add 3 to 5, and it's going to give us 8. So n is 8. Okay, that's answer B. Watch out for the trap of 15 here, which is hoping that you'll multiply the exponents. And multiplying is the wrong move. It's the wrong rule or situation. So again, we want answer choice B. Question number 2. Which of the following is equivalent to 5 cubed raised to the 4th power? Okay, so here's another rule to remember. A power that is itself raised to another power, and that's typically marked by parentheses, you then multiply the exponents. Okay, so 3 times 4 is, okay, multiplication tables, it's 12. So this is actually 5 to the 12th power. That's answer A. And again, the trap is just the opposite of what we had in the last problem, which is adding rather than multiplying. It's adding the exponents, giving you 5 to the 7th power. Okay, so remember, adding is for straight multiplication of exponents with the same base. But with the parentheses that show the exponents that are stacking in a different way this time, that is where you want the exponents to multiply, because that external exponent, that exponent on the outside of the parenthesis, is governing the expression in a different way than what we had in problem 1. So yeah, answer A. Question 3 involves negative exponents. Okay, this is a tricky one. What is the value of 4 to the negative 2? And this is the third rule you got to keep in mind. A negative exponent means you have to, and I'll put this in quotation fingers or scare quotes, you have to flip it. So here's how you can picture this. 4 is the same as 4 over 1, right? Now comes the flip. Flip the fraction. 4 to the negative 2 becomes 1 over 4 squared, which is 16. And that comes out to 1 over 16. 1/16. That's answer D. Again, here's the thing to remember. A negative exponent will never make the number itself negative. It won't change the value of the final number. What it does is it makes it into a fraction, or requires you to flip the existing fraction. All right, good work. Let's do one last one. Simplify the expression 3 to the 4th times 3 cubed all over 3 to the 5th. And this one is going to ask you to use multiple rules at once. So start on top. Same base, multiplied. That means you're going to add the exponents. So 4 plus 3 is 7. So far, so good. Now we come to the division. Same base, but this time it's divided. And so it works more or less the same way, but in the opposite direction. Instead of adding, you're going to subtract the exponents. So 7 minus 5 is 2, which brings us to 3 squared. 3 squared is 9, so that's answer C. If you keep these basic exponent rules in mind, you'll be doing yourself a very big favor in the CLT quantitative reasoning section.